let's take a look at finding the value of this complicated trig expression. I'm going to work inside the parentheses first, looking for the inverse cosine of 0 and the inverse cosine of 1/2. I'll do these one at a time. Now, when you see the inverse trig function, here's what it's really saying. The inverse of cosine of 0 is saying, find me an angle whose cosine is 0. So I need to think about, where is cosine 0? Well, I know cosine is x over r. So I'm really looking for, where is x 0? Well, I know that has to be on one of the axes here in the unit circle. Cosine, or x, is 0 at the top and the bottom. But we only need one, so we'll find the very first one. That is pi over 2. It happens at 90 degrees. So I'm going to replace the inverse cosine with pi over 2. Now let's do the inverse cosine of 1/2. I know that cosine is positive in quadrant 1 and quadrant 4. If you'll remember, all students take calculus. All trig functions are positive in 1, sine is positive in 2, tangent's positive in 3, and cosine's positive in 4. So I'm going to draw an angle in quadrant 1. Since it's the first time cosine is positive, I'm going to label my triangle so that cosine, or x, is 1 and hypotenuse is 2. That means this side has to be square root of 3. Now, across from your square root of 3 would be a 60-degree triangle. So that means that the inverse cosine of 1/2 is 60, or pi over 3. Now we're done with the inverses, so we're going to subtract these fractions. If you quickly make a common denominator with them, you can see that we are actually finding the sine of pi over 6, or 30 degrees. So draw your triangle. You've got 30 degrees. Across from the 30 is the 1. 2 is your hypotenuse, and your other side square root of 3. So you can see that the sine, or y over r, is 1/2. And that is my final answer for this problem.